Good afternoon, everyone, and welcome to MOS Live Science in Action. In just a few moments, we will be meeting our educator who will be running us through some experiments about twirling to safety. My name is Christina. I will be serving as your moderator today. And although you can see me right now, later on you'll mostly be hearing me as I take in all of your questions and observations. If you would like to share an observation or ask a question today, and you are watching us through Zoom, you can do so by clicking on the Q&A button at the bottom of your screen. Don't forget to include your name and age if you would like a shout out. If you are watching through Facebook Live, you can access the Zoom link by clicking on the description of the Facebook video. And if you do need captions today, you can get those by clicking on the closed caption button and selecting show captions on the closed caption button in Zoom. Now, with that all being said, I would like to invite our educator to turn on his camera and introduce himself.
Hello, everybody. Thank you, Christina. My name is Matt. I'm he, him, and I've got a special guest star today, a potato chip. How many of you at home like potato chips? Now, you probably have some experience with potato chips, so let me ask you, if I were to drop this potato chip right now on the floor to the right of my chair, do you think it will survive the fall, or do you think it will shatter in a million pieces? What's your vote?
All right, we have, it looks like, Matt, like they think it's going to shatter.
Right.
Some folks think it might survive, but we have from Julia and Henry a big shatter exclamation point.
Then let's find out. 1, 2. It's in many, many pieces. So that's okay. I have a replacement, his teammate. And the whole goal of today is to do a little engineering to try to help that potato chip fall in a safe way, not just so that it survives a fall to the floor in my room from a few feet in the air, but to survive a fall of 20 feet to a pavement. Now, to do this, we got to learn a little bit about falling, about slowing down falling, and I'd like you to have a chance to participate at home a little bit. So if you had a chance to get some of those materials that were on the slide, we can use those now. If you didn't get them or don't have time right now, it's quite all right. We actually have a write-up for this activity on our webpage. But if you'd like to follow along at home, we're just going to quickly make what I call some bunny copter blanks. Take an 8.5 by 11 piece of paper and fold it in thirds, like so. So it should look something like this, all right? This does not have to be perfect, so don't worry about the fine points. Next, you're gonna fold it this way and this way at a distance of about 2/5 of the way from each end. So that's about here. Okay, and about here. And again, this does not have to be perfect. And now that we've gotten those folds done, we're gonna do a little cutting. So take your scissors and first, you're going to cut 1/3 of the way up on one of the folds you just made, like so. Then flip it over, and again, cut 1/3 of the way up on one of the folds you just made, like so. And then turn it like this, so that those parts you just cut are up, and that the uncut part is down. And do one long cut right down the middle until you get to that last fold you just made, like so. All right, so you've got something that should look like this, that's got some cuts in places, and then there's only one final thing you have to do. You've actually made 3 basic bunny copters. We only need 1 to start with. So unfold this whole thing, and then what you're gonna finally do is cut down one of these long folds. So just follow along with me. And again, don't worry about perfection. These other 2 you can use for something else later if you want to do multiple trials. But hopefully at the end of this, you have something that looks kind of like this, okay? Now we're gonna finish this in a little while, so you can just put this aside for now. But now let's explore this whole question of what went on with that potato chip and what we have to do to save it. Let's start with why things fall in the first place. Does anybody have any ideas? Why did the potato chip fall?
We're going to give folks a chance to mull this over and type in their responses in the Q&A. Looks like Brian thinks it's due to gravity. So does Morgan and Dave and Riba. We have a lot of gravity responses here.
Okay, so a lot of votes for gravity. That's exactly right. Gravity is a force that exists between any two things. In fact, if I hold this potato chip next to my head, there's gravity between my head and the potato chip. Now, there's not very much. I don't have to worry about the potato chip suddenly zinging into my brain if I let go of it. But the larger things are, the more gravity they have. And because the Earth is so strong, it has a lot of gravity with everything around it. So there's gravity between the potato chip and the Earth. And in fact, it goes both ways. Now, the pull up on the potato chip is not very strong. We don't have to worry about the Earth going up very far. But the pull down on the potato chip is quite strong. So if I don't support it with my hand, down it goes. That time it fell on my hand, it was safe. So that's why things fall. Now there's kind of something funny about gravity that can be a little hard to accept. Gravity creates what's called an acceleration, which can be defined in one way as when something speeds up. So for example, when this potato chip is dropped, it doesn't immediately go zing at the same speed. It starts by traveling slowly, then faster, then faster, then faster, then faster, faster, faster. And it speeds up to a certain point. That speeding up is called an acceleration. But gravity accelerates everything at exactly the same rate. For example, I have here a piece of paper and a book. And what I've just said is that if I let go of them at the same time, gravity will speed them up at the same rate, and they should hit my lap at the same time. Now, we all have some experience with dropping things. Do you think that's really going to work? Do you think they'll both hit my lap at the same time if I drop them?
It looks like we have a lot of folks saying no.
Okay, let's find out. I'm going to pull back a little bit. And don't worry, I have a sheet of plastic on my lap to protect my legs. I'm going to hold these up, drop them approximately at the same time, and let's just see what drops first. 1, 2, and 3. What dropped first?
It looks like Dave noticed it was the book, so did Alexander.
Nice job, good observations. I never quite know how much is getting through the camera, so I like to check. The paper fell much more slowly. Now, the reason for this isn't because I was telling a lie, I promise. It's because of the big thing that's going to help us today. And if you want some proof that things do fall at the same rate due to the pull of gravity, there's actually some proof we have from the Apollo 15 astronauts. When they went to the moon a long time ago in the late 60s, they did a lot of experiments, but one of the really famous ones they did was to actually recreate what I just did. They used some different materials. This is the astronaut, Alan Shepard, and in his right hand, he holds a hammer, and in his left hand, he holds a feather. Now, I don't want to show the video because it's kind of low resolution, and through the video feed, it's probably not going to look that great. But the link is right on NASA's webpage. It's easy to find yourself if you want to watch the whole video. But in the second picture, that shows, even though it's hard to tell, the hammer and the feather hitting the surface of the moon at the same time. So if that works on the moon, the question is, why didn't it work here? Well, let me ask you, can you think of something the Earth has a lot of that the moon does not have?
We have a few thoughts here, Matt. So Claire, age 11, thought the book fell faster because of the weight. Julia and Henry talked about air resistance. Supreet said there's less gravity on the moon. And Valerie, age 15, is also referencing gravity.
Now, that's absolutely correct. My friends who pointed out that the moon has less gravity, significantly less, which is why if you go to the moon, you can be a terrific basketball player, no matter how tall or short you are. But even on the moon, even though it will pull things at a slower rate, it still pulls things the same. So what really made the difference here with my book and my paper is simply the air that somebody mentioned. Whenever something is falling through air, it has to sort of shove it out of the way. Plus, there's some rubbing of the air against the sides, some frictional forces. So all of those forces together create what we call drag. And when something is falling, drag acts like a force up to sometimes slow something down. Now, drag affects everything, by the way, not just things that are falling. For example, when you have airplanes that are flying through the air, well, what's moving them is something different we call thrust to move them sideways. Generally, we want our airplanes to stay up in the air for a while. But as it's moving through the air, there's a drag force that goes the other way. And when a rocket is launching up in the sky, it also has thrust that's launching it up. But the drag in this case works the opposite way. The resistance as it pushes through the air is actually pulling the rocket down a little bit. So drag is a big deal. And basically, this is what goes on with our book and our paper. The book, since it is heavier, since it has a lot more stuff in it, has a much easier time pushing its way through that drag. The paper, not so much. Now, if you're having a hard time believing that just being lighter is the issue, and that the drag is really the problem, there might be a way I can prove it to you. I can actually make this paper fall almost as fast as the book by simply taking it and crumpling it up into a ball. Because now if I drop it, it's the same weight. I haven't changed how much paper is there, but it's going to be contacting a lot less air. There's less air to push out of the way. And this time, it should fall pretty fast. And if I really want to drop a piece of paper fast, let me show you the best thing of all to do. I'm going to take one last piece of paper, just fold it, and the only reason I'm folding it is that'll stiffen it up a little bit so it doesn't go woohoo, all right? But now, instead of dropping it this way through the air, I'm going to drop it this way through the air. 1, 2, 3. Did that drop pretty fast?
It sure did. And it looks like we have a few folks referencing that the air was still pushing back a little bit on the paper, but a little bit less.
Yeah. I mean, all it can push against is that tiny little edge. And there's also some friction between the paper and the air as well. But still, we reduced the drag quite a bit, so it fell. So this sort of gets us to our engineering problem. We now know why things fall, and we now know how we can slow them down, but I want to make sure that we can really do this. So we have to kind of think about ways that we take advantage of drag to slow things down as they fall. Can anybody think of something that people have invented to use drag in the air to slow them down when they fall?
It looks like Supreet had mentioned that you can get a lot of drag in a parachute. Claire, age 11, agrees. Catherine mentions a helicopter, and we have quite a few more parachutes coming in right now.
Parachutes are a great guess. It was certainly one of the first things I thought of. Parachutes have a huge surface. They come into contact with lots of air, so much that they can not only slow down people as they fall, but even things like, well, whatever that is, some sort of a missile, I guess, or tanks. I mean, they can drop incredibly heavy loads with parachutes. And somebody mentioned helicopters, by the way. Helicopters usually use their engines to fly, but if the engine breaks, they can actually do something called auto-rotation that partly takes advantage of drag so they fall to the earth more safely. And by the way, just to give nature some props, can anybody think of something in nature, some kind of a living thing that might use drag to fall more slowly?
We have a few folks talking about birds and leaves and seeds. So we have not just fauna, but we have some flora here as well, including some sycamore seeds.
Those are great guesses. All kinds of animals use drag to fall more slowly, including things like lizards and flying squirrels. But I definitely, first and foremost, think of things like seeds, especially a dandelion, where they're so much fun to pick up and blow because those little fluffs at the top make them fall very slowly. And more importantly, from the dandelion's point of view, if a wind, even a small one, catches those little seeds, they could carry the seeds a long distance, which means the dandelion can spread out its seeds and has a better chance of surviving. So basically, what we want to do is come up with a way of increasing the drag to protect our potato chip. And that brings us back to our bunny copter. Now, by the way, if you wonder why I keep calling it a bunny copter, it's because back in the day, I've been working at the museum for a while, we used to put these little cartoon rabbits on them, you know, the ears or the thing, whatever. I mean, it doesn't really matter what you draw on them. Some of my colleagues are less enamored of the rabbits than I am, but I like them. So you don't actually have to draw a cartoon on yours, but let's finish it up to show you how it works. Everybody take your bunny copter if you made it, and you see the bottom parts where you cut them at the top. So just sort of fold them towards each other so that it looks like that. And again, this does not have to be super. Okay, so what Matt's going to do is he's going to really quickly make some cuts in the other bunny copter.
And Matt, maybe while you are working on your second copter, we have a question here from Morgan who asked, why are there no square parachutes?
That's a great question. Now, I actually have seen, when I was doing research for this, I did see square parachutes, but they tend to be designed for a different purpose, not simply falling without control, but with those square parachutes, the person who's at the end of them can pull on a cord and dip one corner or the other, and that way they can actually control how they fall. They actually not fly, but they can actually glide to the ground and actually choose where they land. So that's a great question. I also saw that Leonardo da Vinci, who was a very famous scientist and engineer, back in his early days, came up with a original idea for a parachute that did actually have a square cross section. What a great idea. Okay, we're back in business. I'm going to try to pull this a little less vigorously. So take those bottom parts and fold them behind. All right, so we're almost done with it. Now, if I drop this like it is, do you think it would go slowly, or do you think it would just fall like that last flat sheet of paper I did? Do you think it would fall quickly?
Looks like Viva thinks it will fall. So does Alexander thinks not only will it fall, but it will fall fast.
Okay, let's find out. 1, 2, 3. That went pretty fast. So right now, no help. And that's because it's still flat, so there's not much drag. It's going to slide through the air really quickly. So the second to last thing you have to do to make this work is you have to fold the ears in opposite directions. Now, opposite, because if they fold in the same direction, that would create some drag, but it might cause it to sort of do a loop-to-loop. If we fold it in the opposite direction, then they face the opposite ways the whole time, and they have a lot of drag as they go down. Also, take a paper clip if you have one and put it at the bottom. The main point of the paper clip is just to keep it from flopping over so that it's falling like this. With the paper clip there, that applies something called a torque that will twist it so it falls properly. But there's one final really fun thing about bunny copters. Since the ears are offset, since they're on different sides, that means we can actually turn some of that drag into a twirling force. Now I'm going to show this to you in a couple different ways. First of all, back here, I've got a fan sitting on my bed, and I made a bunny copter and hooked it up by a rope. This sometimes works better than others, so bear with me. I'm going to turn on the fan and see if I can show you this twirling in level. Not bad, huh? Woo. So basically, in that case, as the airstream was coming up and hitting the ears, they were not only pushing the ears up, but they were also applying some of that push in opposite direction, so the bunny copters spun. So this is the basics of how bunny copters work. If you drop them, they'll fall, and the drag will make them go more slowly and make them spin. Well, I took a bunny copter and hooked up another potato chip to the bottom. Let's see if it does slow down the potato chip. I'll be right back. Oh, sorry, not supposed to do that. Okay, here we go. Dropping my bunny copter from 3 feet high. 1, 2, and 3. Now, I know that was a pretty short distance, but did you see it spinning as it went down?
They could. It looks like Vivian, age 8, really liked the way it twirled.
Awesome. I do too. That's why I like these so much. Oh, crud. All right. And sorry, I just rolled another one that I broke earlier and turned into about 50 million little pieces. All right. That's what vacuum cleaners are for. And you'll notice that my potato chip did all right. But remember, we said at the beginning, we were going to try to solve a big problem, way bigger than this. We're not going to just drop potato chips on bunny copters from 3 feet above the soft bed. We're going to drop them 20 feet high onto what? Do you remember we're going to drop them on?
I think folks are still thinking, but Supreet said pavement, and Valerie says pavement, and Dave says concrete. So lots of hard things.
You got it. So the first step in engineering is to really think about your design. And I got to tell you, while this works pretty well on my soft bed, I did not think that this would succeed in keeping the potato chip intact if I dropped it from 20 feet onto something hard. I just didn't think it would work. Now, I didn't know. That was something I had to test. But I started with that assumption that this would fail. And I wanted to try to come up with ways to change my bunny copter that would give it more drag and protect the potato chip. So that's the whole goal, is we want this potato chip to fall as slowly as possible. Now, before I show you what inspired me, I'm curious about your own ideas. What are some ways you can think of to change a bunny copter so it falls even more slowly?
Folks are still thinking. And as a reminder, you can put in your predictions through the Q&A button on Zoom and access the Zoom link in the Facebook description. Looks like Alexander thinks you can make bigger ears or lengthier wings. Karen says if you had a parachute on top, the chip wouldn't break. Bihan says age 11, you can add a parachute. Robert, age 6, thinks you should add some feathers.
Ooh, these are great. Nobody thought of these when I was talking about this idea with my friends. And some of them are scientists. Those are amazing ones. Now, the ears one that somebody came up with is really easy for you to try. That's one of the things that's kind of nice about having several of them already made, because you don't necessarily have to fold the ears right here. You could fold them even farther down. You could even make these cuts way down here and give yourself huge ears. So this is something you can absolutely try at home. I hope you're trying your bunny copters now if you made them, but you can easily modify them to have different amounts of ear. I love your idea about adding feathers. That's adding a little bit of nature to things. And then adding parachutes, I think that's really cute as well. There are flying things that often have small parachutes called drogues that they deploy to help slow them down. So those are all great ideas. Now, I didn't think of any of those myself. I got a lot of inspiration from looking at helicopters. So I'm going to show you some of the things that inspired me. This one on the right is called a Sikorsky Sky Crane, and you can see that it is humongous. It's big enough to lift a house. So one idea that I had was to build a really big bunny copter, and that's this one I have right here, a little bit larger than my small one. And then another one of my ideas, or a bit of inspirations, was this bunny copter over here that had 2 rotors. That's called a Chinook specifically, but there's lots of helicopters that are called tandem helicopters. So I made a bunny copter that also has 2 rotors, okay? 2 bunny copters attached to a frame to hold the chip. And then the final thing that inspired me wasn't actually a helicopter, but it was something I saw in this picture. What you're looking at in this truck isn't part of a helicopter, it's part of a wind turbine. It's one of the blades. And I want everybody to look carefully at it. Does it look flat or does it look kind of round?
Well, we have one pop culture reference here, Matt, about get to the chopper. And then we have a few observations that it is round and it has a curve.
Nice. Yep, there's curves all over the place. Because while flight is a fairly complicated undertaking, in case I do have a few aeronautical engineers out there, I definitely don't want to shortchange that. But one thing you can see on blades of wind turbines and propellers on airplanes and wings on airplanes is that there's some curvature there, and that has an effect on how things fall. So my final design idea is what I call the wing copter, and I used some stiffer material and I added these little curves to the top of the blades. So these were the 3 things I wanted to test to see if they were working. And to do this, I went out to a local parking lot with my friend Max, and we actually tested each of these one by one. So Christina, do you want to try to play the videos and see how that works?
Sure, I can go ahead and do that. Let me have a moment to share my screen.
So we'll show you these one at a time.
Alrighty. So,
all right. So this is the control copter. This is just the basic helicopter by itself, the one I just dropped onto my bed, in fact. So my friend Max there is going to try dropping it from 20 feet high. Let's see how it does. It seemed to flutter down pretty well, okay? Now we'll take a look at the results in just a moment, but now let's look at the test of the next helicopter, which I think is the wing copter. All right, so here goes the wing copter. And again, it kind of fluttered down pretty well. And now we'll try the giant copter. That looked terrible. And now we'll try the tandem copter, the one with 2 bunny copters. Not bad, huh? So this is basically the 4 tests we did. And now we'll show you the results. Christina, do you want me to take over again?
yes, I would.
Okay, so let me show you what we had there with our results, because what I actually did afterwards was I went up and took a picture of each of these copters. So this is the control one, and notice that the potato chip, what do you think, audience? Is the potato chip intact or is it broken?
Oh, it is shattered.
Yeah.
Valerie says it's broken.
Yep, either that or Max took a bite on the way down. So that one is a fail. All right. Now, the second one we dropped was the wing copter. What do you think of the potato chip on the wing copter? Did it survive?
It looks like Claire, age 11, thinks it broke a little bit. Anushka says it's broken.
The problem with these potato chips is because they're curved, that edge might look like it's broken, but I want to promise you it was actually fully intact. So I'm going to give that one a smiley face. But now if you look down here at the giant copter, did you see how that just kind of went right through the air? That's a very scientific term, I know. But do you see any damage there?
Yes, they notice a slight chip on the right side.
Yep, so that one didn't make it. And then finally we have the Tandem Copter. And how does that look?
They thought the tandem one looked great, looks good, looks perfect.
Yep. So the Tandem Copter seemed to work the best of all. And you notice also it just looked like the one that seemed to float the best the moment it was released. The others seemed to have a struggle getting going. So one of my favorite things about doing projects like engineering is I really wasn't sure how this would all turn out. In fact, if I were to be completely honest with you, when I tried these experiments a couple of days ago under slightly different circumstances, the control one actually worked all right. And now I'm kind of curious about why that was. Did it have to do with the air quality? Did it have to do with what it was falling on? Maybe when I did it that first time, it was a little bit shorter of a height. A lot of times in engineering, you have to be pretty patient and do things again and again and again to really get a sense of what designs work the best and what things might need to be re-engineered so you can get your potato chip twirling to safety. So that concludes what I wanted to share with you. And I didn't want to leave you with an absolute answer because you can see there's so many other different things you can try. Remember that we have this template on our webpage. You can print that if you need it. But honestly, it's also just as simple making them as I showed you live. And there's so many different ways you can change. I'd be curious if you come up with completely different ways. And if you do, I hope you'll let us know through the Museum of Science at Home website. So Christina, do we have time for maybe a couple last questions if anybody has, or should we wrap up?
I think we have one question here we can ask. It goes back to the propellers, which is how many wings does a propeller need to have?
Oh, that's a great question. I believe that you can have lots of different ones. I know that there's some helicopters that have 2 blades of the rotor, some that have 3. I don't know if I know of any that have 4 or more than that, but it might just be, no, I take that back. There's a helicopter called the Jolly Green Giant. Yes, that's really what it's called. And its rotor, I'm positive, has 5 blades. I also know that when you look at the propellers on airplanes, they sometimes have different numbers of blades. I don't really know why that is important from an engineering standpoint. That's something now I want to find out more about. It's something you could research too.
Excellent. And one thing that I'm really excited to see here, Matt, is we have folks saying, like Avery, age 5, that she dropped a ruler. Valerie saying she was going to add twill to a parachute for the bunny copter. And
Cool.
someone saying maybe they could use it. Cindy said, attach a paper airplane to it. So it sounds like we have a lot of folks who are ready to continue their experimenting after this.
That's great. That's great to hear. And that's what we're here for. So thank you so much for joining us today. I'm going to turn things back over to Christina, and we hope you have great engineering.
Great. And thank you, everyone, for all of your wonderful responses, both for the questions you asked and for all of the observations you were able to share. I'm sorry that we're out of time and we can't take any more observations and questions right now, but I did want you all to know that we do have more of these programs happening throughout the week. So if you would like to check out more of our schedule, you can visit our website at www.mos.org. Also, you will notice that we have those activities that Matt mentioned at the very beginning. So if you'd like to do the copter engineering activity or other activities, you can see the link to that on the main museum website. And if you enjoyed this program today, we would definitely encourage you all to visit our Science Matters campaign. You can see that at www.mos.org/sciencematters. We hope you enjoyed the program and have a wonderful day.